Okay, we will be again looking in the yellow slice, and we will be making mean, median, and mode comparisons. Now, once again, this is one of these rather frustrating lessons that we get into. We'd be much happier to simply calculate the values of the mean, median, and mode, but instead, ALEKS wants us to answer some questions or make certain decisions about these different types of averages so that we don't just basically make calculations, but we kind of understand it besides, and that's somewhat difficult. So notice that they will give us a sorted list of values, and then they will give us the frequency histogram for those values, and then they begin to ask us questions. So the first question says, which measures of central tendency do not exist? Do not exist. A key word there for that would say have an answer. Which values do not have an answer? Well, only the mode even has the possibility of not having an answer. Let's look at our notes here quickly. Now remember, a mode is based on the number of repeated values in the list. So if there's nothing repeated, we would have 0 repeats. We might not have any modes at all. In that case, they would say the mode doesn't exist. If there's anything repeated at all, and that's the only number that's repeated the most frequently, then we might have 1 mode, 2 modes, or possibly more modes. So the only time the mode doesn't exist is if nothing is repeated. But the mean and median always exist, so you don't have to worry about them. Only the mode is at risk here. So let's go up and look carefully at our list here. And the main thing is, do we see anything repeated? And right away I do. Look, there's 41. It's repeated. Now, there may be other repeats. We don't even care. The fact of the matter is, if anything repeats, then there must be a mode, and therefore the mode must exist. So that means the mean exists, the median exists, the mode exists. So none of these do not exist. So they're playing with double negatives here. None of the measures do not exist, which basically means they all exist. There is a mean, a median, and a mode in this problem. Now on to the second part. Now suppose that the measurement 34, the smallest number on the list. Okay, so we go up here and look at that. We say, okay, yeah, 34 is the smallest number on the list. Now what if that number were replaced by a 17? What would happen? What would change? Well, what would happen is the mean would change, because when you calculate a mean, remember you add up all your numbers, divide by the number of numbers. So since we're making a replacement here, the number of numbers is still the same, but it's not going to add up to be the same thing. The sum will be different because we've changed one of the numbers. So that's going to change the mean. But it is not going to change the median, because remember, the median is the middle value. We still got the same number of numbers on our list. We didn't touch any of those middle values at all, so the median will remain unchanged. And unless, of course, one of the very first values was a repeated value, which it isn't, then that is not going to affect the mode either, so the mean is the only one checked. And as a hint here, I can tell you that on every one of these problems, the mean is the only one checked on the second box, as a rule. Now as we head into this third one, now this is where we get into some work, because it says, suppose that starting with the original data set, the smallest measurement is removed, taken out altogether. So we simply go up here and block out this first one. It doesn't exist now. What's going to happen? Well, that's going to change the mean, because remember, the mean is what you get when you add up all the numbers. So they're not going to add up the same, and they're not going to be divided by the same number either. So that is going to change. But the median, though, Now that's the tricky one because we are in fact going to have to do work here. We're going to have to calculate the median both ways and see if it changes. Now I've done this lots of times and sometimes it does change, sometimes it doesn't change. The mode's not going to change, so it's the median that we really have to worry about. Let's go up here and calculate this median two ways. Well, first of all, we look up here on our original list. And so on the original list, before we take anything out, we see here that there are 22 numbers on the list. So let's go ahead, jump over here, and calculate the median off of the original list. So as we do that, we'll hop over here, take a quick look at that. On our original list here, we have an n of 22. So in order to calculate the median, remember we're going to take half of that. So we're going to take half of 22, which is going to be 11. Now 11 is a whole number, so that means that if we have a whole number, we're going to have to look up the 11th one and the 12th one on the sorted list, add those together, and divide by 2. So let's go back and do that. So on our sorted list here, we have the 11th and 12th, so let's count it out there. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now the 11th one on the list is 49, and the 12th one on the list is 49. So 49 and 49, we could add those together and get 98, divide that by 2, but amazingly, we would get 49 for that. And so the original median with our list of 22 items is 49. That's nice, but we don't know a thing yet. We don't know how to answer our question. What we're going to have to do now is go back and check it here. Notice that the smallest measurement is going to be removed. So we're going to go up here now and put our cursor right over that first measurement, which means that we're going to now have only 21 items on our list. So we're going to have to do this median calculation once again with an n of 21. So let's go over there and let's do that. So we're going to have an n of 21. So we're going to have 21 divided by 2. 21 divided by 2 is going to be 10.5, which is a decimal. Now, of course, if you arrive at a decimal, you're going to round up to the 11th one. You're going to begin counting. Of course, since we took the first one out, we got to be careful now. This first number isn't here anymore, so put your thumb over that one and count out 11 values. Well, when you do, you will find that you're going to be, if we don't count that one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right there at the 49, which used to be, of course, remember the 12th value, but since we took the first one out, we have 49 there, and since we have 49 now for both medians, notice that the median didn't change. So if the median doesn't change, we'll just check that here in the box. Let's see what they're asking here. It says all that would be changed. Well, the median didn't change, so we don't check that. So all of that work to find out that we don't check it. But you have to do it every single time, because if you don't, then the very moment that you think it isn't going to change, it will, and then you'll get the wrong answer. Okay, so what we have then is the last question. And in that last question then, we have the issue here of one of two things. Now, in this particular question, they're asking us about the mean, the median being larger or greater. And sometimes what they will do there is they will ask us about the skewness of our diagram. So let me give you a note here that will sort of help that along. And we'll show you that right now. Okay, now for this last question, you must refer to my beautiful artwork here at the bottom of my notes. Now, if you were to trace the tops of the bars of your histogram, if you're just to trace the top edges of those bars, and the basic shape looks something like this, we would call the distribution negatively skewed. or that means that there are a few very, very small values way out here on the left end. Now what that's going to do is to cause the mean to be pulled, that the mean is susceptible to pulling by a few small numbers, and the mean will be less than the median or the middle value. If the basic shape of the graph looks like this, we say that the skew is positive and the mean is going to be greater than the median. If the graph looks like this, it's roughly symmetrical and you can't tell anything about the relationship between the mean and the median. So what we do now is click back over here and look at the graphs that we have, and we notice right away, look, the short bars are over here on the left side and then the tall bars are over on the right hand side. So right away we call this situation negative skew, and if that's negative skew, that means that the mean is less than the median. And so let's go down here and answer our question. Mean is less than the median, so that means the median is greater than the mean. So we check the second box and we check it. And once again, this one can be a frustrating one to students. Practice, practice, practice on this one.